All right. Again, we spent a good 2 days going over this. Now, there's one proof on here definitely I want to talk about. I would not expect you to know how to do it. Again, because they're asking you to write a paragraph proof, which basically just means say in your own words how to prove it. All right, we're not doing that. All right, you're going to write out all the steps. All right. Now, so open up to 2-5 for me, and then I'm not sure exactly where we left off. Does anybody want me to go over anything outside of the proofs besides like question number 8? I'm going to do the proofs right now.
There's another one up there.
What about
I'm going to do 8 with you and 7 with you. All right? Which will lead in great for today because there's proofs all over today. What?
Are you doing 8 logic?
Well, you find out in a minute. What?
Number 4 on 2-5.
Right here?
Not that one. I think
it's the word property?
This one?
that number.
Oh, yeah.
If 3 planes have a point in common, then they have a whole line in common.
I said no.
I said 7 circles.
I said always.
Well, if
I said no.
they have 1 point in common,
1 point is common number 1.
but what I guess what they're trying to say is it possible that 3 planes intersect at 1 point?
No.
Yes. No. Oh no.
No, because they intersect.
Right, exactly. Their intersection is a line. So if you say, for example,
They can't.
Can't they?
There's like on the cube and there's like on the corner. Within it has.
but remember it extends indefinitely.
Wait, but what if it's like 3 times?
So this is what I was trying to tell you yesterday about, even though what you're saying is true, the triangle might just be the shape for the plane, right? But it doesn't stop there. It just grows, right? So like what I'm trying to say is the board here is a plane, and it's stopped at the borders. But a plane extends indefinitely in all directions. So a triangle, to me, is not a really good representation of a plane. Does that make sense? Right? It would have to be either a square or a rectangle, something that I think would be better for your brain to see that it's going in all directions. Does that make sense? Right? Quickly. Well, hold on. We're still kind of trying to determine this. It says if 3 planes have a point in common. Now, what I would do is, we could almost draw, for example, a box. Now, I know someone was trying to tell me or try to say, well, what about that right there? That would be a point, correct? Right? Now, that point is common. Does everybody see that?
Yeah.
That if 3 planes have a point in common,
Okay, so that one's on 3 planes.
yes, that's what I'm trying to demonstrate. Does that make sense? Right? Well, that's what we're talking about right now. So, does the intersection of those 3 planes intersect at a line? Does everybody agree with that?
Not all 3.
Right. And if I extended, I'm trying to draw this. Sorry, hold on 1 second. I'm trying to draw this so I could extend the plane, maybe so you could see it better. So let me just see if I can do that. Like if I extend this way, right? And then this would be extended if I extended it this way. Right, I'm just trying to get you to visualize. So that's the top plane, and now I have the what? The back wall. Do you agree with that? Right. And so now my question to you is, Yeah. I think that intersects at a point. You agree with that?
Yeah.
You see what I'm saying? However, you could also draw this.
Even if there wasn't at a point, you could still go.
That's exactly correct. But, so what I'm trying to do now is I'm trying to demonstrate this now. I think that's good. Look right here. If I include that, does everybody, you see what I'm saying?
Okay.
Now if I go this way, right, that point intersects all three of those planes, correct?
Yeah.
But now I can get it to where that, hopefully you can see now, is a line. Does everybody agree with that? That the intersection of those
Yeah.
three planes could be a line. Yeah, yes, sometimes. All right. Now listen to me on this, guys. Listen, my goal here right now, is maybe there'll be one or two of those. We're just trying to visualize things, right? Because I do understand some of you have a hard time visualizing. Right, so the intent right now is just to try to teach you how to look at things that are hard to look at. That makes sense, right? So it's very difficult for me to draw that out, to get you to visualize. The only way you can visualize it is try to think about it on your own and try to draw things out. That's the only way I knew how to come up with that answer for you. All right? I didn't sit here and say, yes, that's the answer. I had to do what? I had to draw it out to demonstrate. And I draw it out and I try to come up with an alternative answer. Or I try to prove, I go in trying to prove that it's not correct. And when you do that, then you'll start to see other possibilities. All right, that's what I'm hoping you can do. All right, quick.
Can you just show me where they have a line common?
Yeah, this right here. That's a good question. That would be in common.
Wait, but how does that go with the back one?
Okay, so I made it doesn't. I made a third plane, right? So this right here is. So I changed it up a little bit. So this plane right here, right? This plane right here, and now the plane going vertical this way, right? They share this point.
Oh.
They share this point. However, they also intersect to form a line. True? Right? Because I created a new plane. It's like, think about it like the pages in your book. As you open up the pages in your book,
Okay, I see.
they're the seam, right?
Mm-hmm.
So you're flipping a page.
Yeah.
All right? So it's possible. But if you're looking strictly at the corner, there is a point that fits on multiple planes. All right? So again, like I said, I totally understand, John. All right? That's not the important part, but it is a good lesson just to try to get you to see things differently. All right, quickly, yeah.
Maybe number 3.
All right, let's take a look at number 3. Let's see how you do.
Not that.
Not this one? Right here? Well, but it's what they talk about when they hear sound, right? And they have 3 locations. So if somebody, let's just say, for example, there's an earthquake, right? The sound waves travel out, right? And as they travel out, they'll have a receiver here, right? They'll have a receiver here, and they'll have a receiver here. You with me? And then what they'll do is when they hear that sound, they'll figure out how long it takes, right? How long it took them to hear that, and it'll do something like this. They'll be able to create circles, all right? So they'll be able to create circles, and then where those circles intersect is the location of the sound. Does that make sense? Just traveling, all right? But let's look at this. All right, it says a sailor spots a whale through her binoculars. She wonders how far away the whale is, but the whale does not show up on the radar system. She sees another boat in the distance and radios the captain asking him to spot the whale and record its direction. Explain how this added information can enable the sailor to pinpoint the location of the whale. Wow. I'm listening.
Okay. So so with that alone, she would have to know where the boat is. So if she didn't know where the boat was, then that idea would fail. But if she knows where the boat is, then she can pinpoint, go to the boat's direction, and then go to where the whale's direction was.
Okay, so this is just what I'm kind of getting what you're saying. So you know where you are, and you spot the whale, right? She sees another boat in the distance. All right, so here's another boat over here. Oh, does it really matter?
Closer to the
All right. Ask him to spot the whale and record its direction.
direction, different location. Because then that makes a difference.
Yeah, you know what I'm gonna do is, who asked me about this? I'm gonna look this up. To be honest, I'm not 100% sure, because explain.
Well,
How does this help her find the whale?
Yeah, let me. I'll look that up and see what it says.
Okay.
All right. And again, if I want you to remind me tomorrow. All right. That way I can look it up, because I'm not exactly sure what they're trying to get at, because again, all right, on the ocean we're on something that's round also. Does that make sense? Right. It's, so again, I'll try to figure out what exactly they're asking. But again, here we go. Listen, I want to jump real quick. No, I want to go to the proofs real quick because we're running out of time. All right, I want to talk about the proofs that I want you to look at. And let's look at question number 8. All right. It says, in the figure at the right, point B is the midpoint of AC, and point C is the midpoint of BD. I want you to try to prove that AB is equal to CD. All right, so let's start this out. Hopefully you did, or you gave it a shot. All right, so here we go. Statement and our reason. Number 1, B is the midpoint of AC, and C is the midpoint of BD, and that reason is what? It's given. That's the first start. All right, so given. All right, now, as soon as they say point B is the midpoint of AC, then I can mark what is true. What can I mark?
B is equal to C.
Well, you would say what, Carter?
AB is equal to BC.
Yeah, you see what I'm saying?
BC is equal.
Hold on a minute. I didn't ask you about that. I just said if B is the midpoint of AC, you would have to write that down as given. And then step 2, all right, you would say then, Carter, what? AB is congruent to BC, and we would say that is definition of what? Of midpoint. So I agree with that? Then step 3, we could say what? BC is congruent to CD, and that's fine. Again,
I just put that under 2.
I'm okay with that also. I don't really care. All right, that's definition of midpoint. Now what I want to do is I'm going to mark it with what? 1 tick mark, right? Why can I mark it with 1 tick mark? They're congruent, right? Everybody with me on that?
Yeah.
Go ahead.
So AB is congruent to CD.
Exactly right. So there you go. AB is congruent to CD. Now, here again, we can say substitution, or we could say transitive property. If A is equal to B and B is equal to C, then A is equal to C. And every year we have a discussion about what's the difference between transitive property and what's the difference between substitution. You can, if you want, put substitution in every time. All right, and every year I ask the kids to go look up on the internet the difference between transitive property and substitution property. And I'm trying to tell you. All right, so for transitive property and substitution property, it makes no difference to me what you put down. All right. Generally, you would use the transitive property. They say if two things are equal to the same thing. For example, AB is congruent to BC. Then it has written BC is congruent to CD. Then you can say AB is congruent to CD by the transitive property. All right. It's also a substitution because all we're doing is taking BC and replacing it with what? CD. It's the same thing, guys. All right? There's a minor distinction. All right? Now, the transitive property has to be in a particular order. AB, BC, BC, CD, AB, CD. So that's what I'm getting on that? All right? But again, I'm not going to have a discussion every year. We waste 5 or 10 minutes of class trying to iron that out. I don't care what you put. All right, whether it's transitive property or substitution property. All right. Now let's move on, and that's it. Does everybody agree? Come on. That wasn't that hard now. All right, it's really not. All right. So now let's look at the next one. Let's look at 7 real quick. All right. So again, let's go ahead and begin. We have statements and we have reasons. All right. E is the midpoint of A, B, and C, D. Now, if E is the midpoint of A, B, and C, D, does that mean that all 4 of those are automatically congruent?
No.
Very good, guys. That doesn't mean, because one could be 10 units long and one could be 2 units long. All right. So we don't know that. Everybody hear me on that, right? So step number 1, just in the interest of time, you would write that out, but I would just say given. All right? Now, yeah, I don't know why I'm doing that. Thank you. All right? Now, step number 2, E is the midpoint of AB, so everybody should be able to clearly say now what?
AE plus
Everybody, AE is congruent to EB. Is everybody happy with that so far? And then if you want, you could now mark it this way, 1 and 1, right? And now, well, yes, in a minute, the next step would be what? Right. Now I'm going to put 2 tick marks right here. Does everybody agree with me?
Yeah.
Because we don't know that they're congruent yet. We don't know that they're congruent yet. We're going to get there. All right? So step number 3, we could say, well, actually, if you want to, you could just say what? You could say CE is congruent to what? ED, and that's the same definition of what? Of midpoint. All right? Now again, we're trying to prove AE is congruent to ED. Yes, ma'am.
Okay, so I don't understand, like, AE is congruent to EBCE is congruent to DE. I don't understand how you get the definition of midpoint or the transitive property. I don't understand how we know any of it.
Well, I haven't said transitive property yet.
I don't understand where you're getting it.
How about when I read the problem? It says E is the midpoint.
Okay.
So if E is the midpoint of AB, what can you conclude?
That A, E, and DE are the
Congruent.
same.
Congruent. That's what the midpoint says.
Okay, that's
Without the knowledge of midpoint, you can't say that.
Oh.
Right? The same thing here. Now, did you understand what I'm saying? Is I can't tell you that CE is congruent to EB yet because they don't have to be the same length.
Okay.
It's loading.
All right. What?
Oh, I think I know how to solve it.
All right, what?
In the directions, it says AB is equal to CD.
Yes.
So you know that they are
Hold on a minute. So, what?
Well, I was gonna say that. So
What?
That, so that way you know that A, B, and C, D are the same. So that way their midpoints are going to be the
Not
same.
exactly yet. Not exactly. You're correct. Both of you. You're correct. But before we can say that, here's what I need for you to be able to say. I need for you to be able to say that that AE plus EB is equal to AE and
You mean AB?
what?
You mean AB?
Yes, thank you. AB. Thank you. Does everybody see AE plus EB is equal to AB? That's okay. Then you can also say that CE plus ED is equal to what?
CD.
CD. All right? And we've already talked about that. That's the segment addition postulate. You with me on this?
Wait, why do you have to do what?
So we agreeing with me on
Yep,
that?
I got you.
All right? Now, we've said in 1 that AB is equal to CD, correct? Right here is where that is. AB and CD are congruent, right? So, now watch what I'm trying to show you. If these are congruent, then these are congruent. Everybody agree with that? Right? So now for step 4, I can say AE plus EB is equal to CE plus ED. Everybody okay with that?
Yeah.
And that is strictly a substitution problem, right? We let AB was equal to CD. So we replaced AB with AE plus EB, correct? All right? And that is what? A substitution problem, right? Now, what does, and I always have to remind myself, I'm trying to prove AE is equal to ED, right? So now look right here. I'm trying to prove that AE is equal to, did I say ED? Right? So I need to get rid of the EB and the CE, correct? So what does EB equal?
CE.
EB equals, come on guys, what does EB equal?
AE.
AE. So wherever I see an EB, I could put
A.
AE, right? So step number 5, AE plus AE equals ED plus ED. That's again just a what? I'm substituting equals.
Okay.
Good so far?
Yeah.
Now, 6. AE plus AE is
2AE.
2AE is equal to 2ED. And we just call that, what are we doing? We're simplifying. Thank you. And then
And then
dividing by 2, AE is equal to
ED.
ED. And of course, that's division property of equality.
What's the division property of equality?
That's what you've been doing to solve an equation. Right? We're simply dividing both sides. The addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality. All right? And again, those, believe it or not, are just what? All right? Those are just properties. All right? You have to accept that as true. All right? So be okay with that? So that's the proof. Again, that's not that hard. It's just annoying because you have to do what? Write out all the steps. Right? And it's so much better than a paragraph. We're never going to write a paragraph. All right? Now, I'm good with that. All right. Now we got to jump into today's assignment because I know I'm running slow, but that's okay. All right, super, super important. All right. Now, I'm flipping now, you guys. Ready? So we're going into now 2-7. All right, I'm not going to make the same mistake I made the other day. All right. So again, 2-7 is again a restatement of exactly what I've been trying to tell you. There is something called the Ruler Postulate and something called Segment Addition Postulate. Is everybody loading this up? Is that what y'all are doing?
Yeah.
All right. So load it up real quick. All right. Now, again, I think the biggest problem that kids have with geometry, and let me just say this again, is that, number one, they're thinking about something else when I'm talking, all right? Or they're not listening to me when I try to explain what the ruler postulate is, what the segment addition postulate is. They're not working with me as I'm doing the problems, all right? And even though I get frustrated with some of you, right, I do, honestly, I do want you to continue to ask me questions, right? Because I'm telling you, it just builds and builds and builds and builds. And if you're not paying attention now, that's why I get frustrated. In 3 weeks or 4 weeks, it's either going to be really what? Easy, or it's going to be what? Impossible. All right? You have to work every single day. If I ask you to do something, even if you don't know what you're doing, you have to go home and read it and look it over. It makes all the difference in the world. And at some point, the light switch is going to go on, and it's going to be easy. It's not at first. And some people, it's easier than for others. All right? So you have to put the time in. All right? You absolutely have to put the time in. All right? And try to listen and understand what I'm saying. All right? First and foremost, now, we're going to talk about the ruler postulate, which I will never write in a proof. All right? And again, I would just say that's what? Common sense. The points on any line or line segment can be put into a one-to-one correspondence with real numbers. Does that make sense?
Yeah.
Right? Every point, you can't say at this point it's 1 inch and it's also what? 2 inches. Does that make sense, right?
Yeah.
Every point has a location, its own location. It can't be in 2 places at once. All right? Although science is kind of trying to say that may not necessarily be true. All right? Again, that's for later. Again, it's fascinating. It's absolutely fascinating. All right? So, again, segment addition postulate, we've already talked about. Again, if A, B, and C are collinear, that means they're on the same line. Then point B, or if B is between A and C, AB plus BC equals AC. We're going to use that a lot. All right? Now, I thought about wiping this out, but this is kind of what we've done already, in my opinion. All right, just to see how you could do on this. All right. So again, Q is the midpoint of PR. R is the midpoint of QS. And what I want you to do on this is, at some point, if you're having issues or if you're struggling, you can do what? You can cover up the answers here, look at the proof, look at the statements, and see if you follow the reasons. Does that make sense? Yeah. Right? These are worked out for you, all right, just so you can get a feel of what's going on. Now, personally, I like writing the entire proof myself. All right? I don't like to fill it in because sometimes I see it differently. That's why when I grade your test, sometimes it takes me longer because I have to follow your logic. And your logic might be different than what? My logic, but your logic still could be sound. Right? So it might take you 10 steps and it might take me 3. But yours is still correct. All right? But if you have to do it like someone else sees it, you might not see it that way. All right? So filling in sometimes to me is not the easiest way to do things. Is everybody with me on that?
Yeah.
All right? So what we're going to do is I'm going to leave you with this. I want you, if you need to go back and just look that over and make sure you're good with what they're saying. Everybody good? All right? Now let's get down here. All right? So let's just fill in. What's the matter? Oh. This is just... All right. Complete these proofs, which I don't think are that difficult. All right. So here we go. It says DC is equal to, BC is equal to DE, and AB plus DE equals AC is what we're trying to prove. So here, yeah, again, some of you will get one question right on the test. All right, because you just put in given for the first one. All right. Then all of a sudden we start to fall down. All right. So the segment addition postulate. What can I say about the segment addition postulate? That's correct. You would say AB plus BC is equal to AC.
And substitution.
And then we're simply replacing what?
BC. Yeah.
That's right. BC replaces DE, and that would be what? Substitution, guys.
That makes sense.
Right? And again, that's what I'm saying.
Yeah.
All right?
Can we make it all that simple
Yep.
for each one?
It is that simple.
Are you doing it like that on the test? To make so many.
Yes, that's exactly. Listen, what's annoying is that you just can't say this is true because I said. You have to explain what you're trying to say. All right? And you have to back it up. All right? That's what you have to do.
Is this what the test is kind of going to be like?
Yeah.
Write it in.
Mm-hmm. Well, no, you're actually, what's going to end up happening is I create some additional proofs, but no, you're going to write them on your own.
Oh, darn it.
All right?
Aw.
Usually the first test is fill in, and I have one or two that you have to write on your own, and then by the next test, you're writing them all on your own.
How many are there?
Oh,
Well, I usually like 10 on a test or something like that.
what is our test?
Probably next Friday. Or Thursday, depending on how well we're doing. All right, here we go. Now for number 2, it says Q is between P and R. R is between Q and S. We're trying to prove that, and PR is equal to QS. We're trying to prove that PQ is equal to RS. So let's give it a shot. Q is between P and R is given.
Yeah.
All right. Then it says, and I like to highlight, PQ plus QR equals PR. Right. Now listen, segment addition postulate. All right, I'm okay with the abbreviation. All right, I'm okay. Shh.
So on the test, are you going to have like...
I'm not worried about the test. Do not ask me about the test. I got too much to do. Now it says R is between Q and S. What is that?
Given.
Listen, I'm not in a position. I'm nothing's funny, right? I'm not interested in that. All right. I don't want you just saying something just because you want to hear yourself talk. All right. I don't understand why everyone in here doesn't know the answer to number 3, because you're not paying attention. If you don't know, that's why. Obviously, William, it's given. That's all you have to write. Now, if I was writing the proof, some people say, can I just put all the given in the first step? That's perfectly fine with me. All right? That's perfectly fine. All right? It doesn't have to be that way. All right? Now, the next step is they want you to do the segment addition postulate again. So we're going to obviously say
QR plus RS equals QS.
QR plus RS equals RS. Is that what you told me?
QS.
QS, thank you. Now here's where you're not just filling in. You're not just writing it down. You're making sure you understand exactly how that is. All right? Now, again, let me explain this to you also real quick. Generally, it goes one step after the other. Now, not always, but 4 is a direct result of what? 3. Right? Now, of course, that doesn't always, but generally, if you're confused, look back at the previous statements. And once you say something, then something else follows from that statement. All right? Now, why does it say PR is equal to QS?
It's given.
Because it's given. Again, unnecessary if you wanted to write all the given first. Now, how do I know that PQ plus QR equals QR plus RS? We can call that a substitution, right? Because why?
It's just breaking it down.
Right, so I exchange, listen to me now. Here's what I'm really trying to show you. So look up, because this, for some reason, is a problem for kids. So I'm going to highlight this real quick for you. Look, I'm going to highlight PR right here. And I'm going to highlight what PR is equal to. Listen to me now. If you're not seeing things, I replaced this PR right here with what it was equal to. That's where that comes from. Come on now, really concentrate on what I'm saying. Does everybody see it? Anybody not see that? Listen, I don't care if you don't. I want to make sure you see it. You don't see it? Okay, so look right here. Again, PR is the same as this. Do you understand that?
Yeah.
Here is where PR is. You with me? Yeah. So now I'm replacing, watch this, I'm crossing out this PR and I'm putting in its spot what it's equal to.
Okay, so
You with me? There you go. Now you see this QS?
Yeah.
That's equal to this.
Yeah.
So I cross this out and I replace it with this. So, hold on a minute. Yes or no?
Yeah.
That's it, guys. The hard part is to look sometimes up 2 or 3 steps to see the substitution. No doubt about it. That's the hard part. No, well, what are we doing? We're substituting one equal for another equal. So that one's substitution.
Yeah.
Everybody good with that? Now, what am I doing? The subtraction property, correct? Because I'm subtracting QR from both sides. Everybody agree with that?
Yeah.
So that's the subtraction property of equality. All right? And so when I subtracted, I was left with what? PQ is equal to RS. Hold on, look right here. What I'm trying to demonstrate right now is I cross that out and I cross that out, right? And I was left with what? Now listen, I'm going to show you something right here. I'm kind of in a little disagreement on this step, so please listen. This last substitution is not right, all right? That's just a different way of looking at it. So listen to me. I'm crossing that out, right? And honestly, I don't really need to see this right here. Is everybody with me? So let me explain what the last step would be. So up here, this is PQ plus QR equals QR plus RS, right? Hold on one second. I'm subtracting QR from both sides, right? So it's just automatically PQ equals RS. Right, I don't need that I don't know what they're doing down there. That was not exactly good. You with me?
So on a test, would you put my answer?
PQ equals RS is what we're trying to prove. Yeah, step 7. No, we're really skipping step 8. Does everybody understand what I'm saying now? All right, listen. That's dumb. Next year, I'm gonna wipe that out. That's not even gonna be there next year. Is everybody with me on that? All right, I'm wiping that out. Does everybody understand that, right? Okay, so now, come on now. I know we're going to snack, so you got to do me a favor. Listen, let me say this. For tomorrow, I want you to maybe read 2-7 right there, and then listen. I'm going to cut you a break. I want to go ahead then and just do this proof right here. Does everybody hear me?
Yeah.
And then tomorrow in class, we'll knock out the last 2 pages together.
Sure.
All right, that's fair enough.
Thank you.
All right.
What is PR equal to R?